Now this is a very famous identity, Euler's identity. We have to prove that e to the I theta is equal to cos theta plus I sine theta. Now first of all, we'll let y equal, the right hand side equal cos theta plus I sine theta. Now differentiating with respect to theta, cos theta becomes minus sine theta and sine theta becomes cos theta. Now taking the I out as a common factor, we have the cos theta here, but we'll have to put another I in there because I times I will give you this the minus 1. So we'll get back to where we started from. Now of course cos theta plus I sine theta is the original y. So dy d theta equals Iy. Alright, now taking y across to the other side, that is dividing both sides by y, we get 1 on y, dy d theta equals I. Now we then integrate both sides with respect to theta. We get this result here. Of course that means that the integral of 1 on y dy is the integral of I d theta. Now this is just log y, and we integrate I with respect to theta, we get I theta plus a constant. Therefore y will become e to the I theta plus this constant. Now what we'll then do is replace that e to the c with an a, and we get y equals a e to the I theta. So a e to the I theta must be equal to cos theta plus I sine theta, because that's what y was at the beginning. Now, because it's an identity, we can let theta be anything we like, so I'll let theta equal 0. So e to the 0 equals cos of 0 plus I sine of 0, which means, of course, cos of 0 is 1, e to 0 is 1, and of course this will be 0, so a must be equal to 1. So if a is equal to 1, then we can say that replace that a was 1, and we get the result that e to the I theta is equal to cos theta plus I sine theta. There's a very interesting little plus about this one, which you might recall. If we replace that theta with pi, we get e to the I pi is equal to the cos of pi plus I sine of pi. So e to the I pi is equal to, the cos of pi is minus 1 and the sine of pi is 0. You might have seen that in some t-shirts that are going around the place. E to the I pi is equal to minus 1. It incorporates the transcendental numbers and the imaginary numbers and the negative integers, which is quite an interesting little result.